Okay, this is term 2, week 9, mechanics. Very simple, really. Maybe one or two questions that are a bit tricky. The rest is all one formula, okay? Basically, today's about collisions, okay? When two objects moving at a certain, two objects of certain mass m moving with velocity v collide with each other, they form either an elastic collision, okay, or an inelastic collision. Okay, what's the difference? Okay, an inelastic collision, actually I'll start with elastic. I'm recording, yeah. Elastic, basically, and I kind of think of it like elastic. When something's elastic, you pull it back, it swings back forward. Like it kind of stays moving, you know what I mean? So elastic is when both objects bounce back or bounce and continue moving. Okay, you can think of it like this. Okay, continue moving, and the keyword here is separately. Okay, however, for an inelastic collision, they're gonna collide. They either stick together or become embedded. Okay, so these are all keywords over here. Okay, stick together and embedded, these are keywords. What are the formulas for each? I'm gonna give you one formula. It applies to basically everything. Okay, P initial is equal to P final. Okay, we know this due to Newton's second law. We know that sigma F is equal to dP over dt. And then you can do some stuff, impulse momentum, blim blam bloom, take stuff to the left, right, prove, derive. I'm not gonna explain it. Actually, I can explain it if you want. صراحة no, it's too much work. It's not too much, it's just a few. I'll do it because actually this was a course division question. In case it might come, because I saw it in the course division. Okay, basically, Newton's second law. Okay, when you have two objects that collide, let's say you have an object C and an object B, you can skip this if you want. But seriously, I saw it in the course division, and I guess it's nice to see it. Because last mechanics CA, he got for you have an object C, object B. Basically, the force CB is equal to negative the force BC. Okay, that's Newton's first law. For every third law, for every action there is an opposite reaction. Okay, let's see these are two balls in billiards, for example, the cue ball, the white tip, and B, the billiard ball. Okay, if you multiply by delta t on both sides, okay, you're gonna get FCB delta t equals minus FBC delta t. Okay, you know that F is equal to MA. Okay, so let's call this MA delta t for CB is equal to minus MA CBC. Not sorry, how am I saying CB? My bad. It's force of acceleration of C, right? And here's acceleration of B. You can't have acceleration of two objects at the same time. Anyways, delta T, okay? And then acceleration times delta T is just velocity, right? So over here, acceleration times time is velocity, okay, of B. And then what does this mean? Whoa, it's not just V, it has to be delta V, because we're talking about the change in time, but it should be delta V. Okay, so what does this mean? It means M, this is mass of B, right? This is mass of C, this is mass of B. That doesn't matter. But you're going to get M delta VC. What does that mean? M VC final minus VC initial is equal to minus M VB final minus VB initial. Okay, so basically what this means is if you expand this, okay, you're gonna get M VC final minus M VC initial is equal to minus M VB final plus M VB initial. So let's take all the initial to one side and all the final to one side. You're gonna get what? M VC final plus M VB final is equal to, take this to the other side, M VC initial is plus M VB initial. So this is the proof of this. What do we call this? This is the collision theory or theorem, whatever. I call this. This is what I like to call it. In simpler terms, call the initial velocity u and call the final velocity v. Okay, for objects 1 and 2, right? In simple terms, m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Very nice. Okay, you can use this for both of these. Some people, they use one for elastic, one for inelastic. I don't like that. I can just substitute here and get the one there. I don't want you to memorize too much. That is the collisions. There's not much you need to know other than that. Okay, for elastic, you need to know that for both of these, momentum is conserved, because over here P before equals P initial. But so for both of these, P initial is equal to P final, right? As you can see by the what's MV? MV is momentum. Okay, so P initial is equal to P final. But for elastic, K initial is actually equal to K final. K any kinetic energy, because sometimes you're going to need to use this to find some things. For inelastic, K is not conserved. Okay, it's not conserved. I hope that makes sense. Let's just dive into the problems. Is there any center of mass here? Nothing. Oh no, Bella, there's one here. So I won't explain it now. Okay, I'm gonna come to 4 later. Okay, because 4 is a bit important. Anyways, because since it's only one question, I don't know why. A perfectly elastic collision is one, and what is conserved? What's conserved in elastic? In both of them, momentum is conserved. But in elastic, what's conserved also? Kinetic energy. I just said this now. Okay, question 2. A cart of mass 8 kilograms is moving at 1.5 meters per second. Okay, so let's call this M1, and let's call this, it's moving initially at 1.5, so U1. Okay, it collides with another cart of mass 2 kilograms, so M2, initially at rest, so U2 is equal to 0. After collision, the carts move together. Okay, if they ask you what type of collision is this, it's going to be in elastic, because they stuck together, right? Type the speed of the carts right after collision. What do we use? M1U1 plus M2U2 is equal to M1V1 plus M2V2. Please, when solving any collision problem, any momentum problem, take the positive direction. Okay, since nothing bounced back here, it doesn't really matter. But I want you to get used to taking a positive direction, like I told you in the last mechanics CA. Okay, M1U1, so 8 times 1.5 plus M2U2, it's gonna be 0. Why? Because it's initially at rest, right? Plus, let's just skip the 0, equal to M1V1, so 8 times V1, we don't know it, right? We're trying to find it, the new velocity of the cart, plus M2V2, 2V2. Okay, so it's going to tell me, wait, how do you solve this if I have two unknowns? And how we know they're moving together? What does this mean? V1 is equal to V2. Okay, so you can just substitute this with a nice cheeky V here, like this. Okay, 8 times 1.5 will be, I think, 20. No, it should 20. But 20, I think. Let's do it. 12. How did I get 20? 12 is equal to 8V plus 2V. So you're going to get 10V is equal to 12. So you're going to get V is equal to 1.2 meters per second. Okay, very easy. Why did I tell you some people use a different formula for inelastic? What people do is they do this, okay? M1U1 plus M2U2 is equal to M1 plus M2V, okay? Why do they do this? Because V for both of them after collisions is the same, so there's no need in doing M1V1 plus M2V2. Since they're the same, they can just factor V and do M1 plus M2. People use this formula. So now I like sticking with this and just using it as equal. So, and you're not stupid. You guys are really, you're all smart grade 11S students. I think you know how to make these two equal and then take them and add the coefficients. It's not that hard. You guys all have a basic understanding of math. Question 3. A mass M1 equals 3 kilograms is moving at 1 meters per second. It collides head on with a mass M2 moving at 8 meters per second in the opposite direction. As a result, M1 recoils backwards at 2 meters per second. Okay, let's analyze the given here. M1 is over here, U1 is over here. Okay, we're gonna take the positive direction to be the direction of 1. Okay, if you want, you can draw it. If you want, you can do this M1 and then here M2. You can do this if you want, to help visualize it. Okay, anyways, so we're taking the positive direction here, and I'm gonna draw it because it makes my life way easier. Okay, so head-on collision, and head-on collision means like this. Okay, it's moving at 8 meters per second in the opposite direction. So we have M2, and we have U2. Okay, U2 is equal to what? -8. Please don't substitute it as 8, substitute it as -8. Why? Because it's in the opposite direction. احنا اتفقنا we're taking the positive direction to be to the right. Okay, that means block 2 or ball 2 or whatever is moving to the left, which is the opposite direction. As a result, M1 recoils backwards at 2 meters per second. So we found V1, and actually they're asking to find V2. Right. Recoils backwards at 2 meters per second. And it goes back at 2 meters per second. After collision, looks like that. So what does that mean? V1 is equal to negative 2. Why negative 2? Because it's in the opposite direction, recoiled backwards. Yalla, formula. M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2. Yalla. M1 3 U1 1 plus M2 2 U2 negative 8. Please don't mix it up, okay? Equals M1 again, right? M1 V1. So 3 V1 negative 2 plus M2 V2. M2 is what? 2 V2. Yalla, solve. This is basic math. 3 minus 16 is minus 13. And then you have negative 6. Minus 13, take minus 6 here, you're going to get minus 7. So you're going to get 2v2 is equal to negative 7. You're going to get v2 is equal to negative 3.5 meters per second. But they took a positive answer. Why? Because he said speed. Okay, speed is a scalar, so you take the positive quantity. And I خوف قلبي. Okay, yeah, good. I was scared I didn't unmute after the knife. Anyways, a question 4, center of mass. Okay, this I'm sure you're going to get a question where you need to apply the formula in your exam. So I'm gonna give you a question from the book. Let me just find it 1 second. Okay. Yeah. فمثلا how the question comes in the book is, well, this is the formula. Okay, center of mass for any object. I'll write it here. For the equation of the center of mass. Okay. The center of mass has, remember, we're in a 2-dimensional plane, sometimes 3 dimensions, right? So every coordinate will have an x and a y. Okay, center of mass in general, whether it's x or y, is equal to m1 x1 plus m2 x2 plus dot 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 over m1 plus m2 plus dot 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 dot. Because sometimes you're gonna have 2 objects, 3 objects, 4 objects, 5 objects, whatever. In the exam, you shouldn't see more than 2 or 3. Okay. This is also called the weighted arithmetic mean. Okay, if it comes, this is just stuff written in the blue text in the book. Weighted arithmetic average of x1 and x2. Okay, what's m? Obviously mass. But what's this x here? This x corresponds to the position. Okay. So let's say I have 3, 5 and I have, I don't know, 2, 7. Okay, and then 3 kg, 5 kg. Okay, you know, I'll give you a proper question that was in the book with the numbers over here. We had a question. It was m1, 3 objects. m1 equals 1 kg, m2 equals 4 kg, and m3 is equal to 2 kg. Okay, and the respective positions were 4, 5. Okay, negative 1, 2, and 7, negative 3. They want us to find the position of the center of mass. The position, any point, I told you, you're going to have an x and a y. Okay, so I need to apply the center of mass for the x and then apply it with the y. Someone's going to tell me, how do I apply it with y? Man, it's easy. It's the same exact thing, but just switch this x with y. Okay, center of mass x would be m1 x1, so 1 times 4, plus m2 x to 8, and I took it give 1 times 4 minus, okay, but yeah, okay, over here, yeah, sometimes look, by the way, sometimes they give you points like this, you know, let me continue. 1 times 4 m1 x1 plus m2 x2, so plus mass 2, which is 4 times x2, which is negative 1, plus m3 x3, which is 2 times 7, okay, over m1 plus m2 plus m3, so 1 plus 4 plus 2. Okay, so let's fix this. 4 minus 4, these cancel. You can get 14 over 7, which is equal to 2.0. Let's just call it centimeter or whatever. But this is what matters. How about y? Again, m1, y1 plus m2, y2. So 1 times 5 plus 4 times 2 plus 2 times minus 3 over m1 plus m2 plus m3, which is 1 plus 4 plus 2, which is just 7. Okay, you're going to get 5 plus 8, 13 minus 6 is 13 minus 6 is 7. So 7 over 7, which is 1.0. 0.0 centimeters. So the location or the coordinates of the center of mass will be 2, 1. Okay, this is how you solve. Sometimes this is a book exercise. They give you points like this. Okay, and they tell you find the center of mass. The center of mass, you're gonna find it maybe here. But the important part with finding a center of mass is this center of mass, you're taking a point with respect to a center. Okay, we don't know what. You're not going to see a question like this in the exam, but in case you see it. Anyways, question 5. Consider two bodies A and B. Mass A is 6, mass B is 2. Body A is moving along a direct axis in the negative sense with a speed of 3 meters per second. So we found u1 is equal to -3, and collided with body B moving at speed 4 in the positive sense. So u2 is equal to +4. Hole A, m1, m2. Okay, m1 on, m2 on. Assuming that the collision is perfectly elastic, the kinetic energy of the system of two masses after collision is what? So here they didn't ask you for speed, they asked you for the kinetic energy. What do we know about kinetic energy in a elastic collision? It's K1 is equal to K2. And to find the kinetic energy after, I can just simply find it before. Type, how do I find kinetic energy? Isn't it half mv1 squared, half m1 v1 squared plus half m2 v2 squared? Alright, so it's going to be half mass 1, which is 6, times v1 squared, which is 3 squared, or -3 squared. It doesn't matter as long as it's positive when you do it, because if you want to put the negative, just make sure you put the square outside the brackets. So half m1 v1 squared plus half m2, which is 2, v2 squared, so 4 squared. So you should get 43. Let's take a look. 3 times 20, here you get 27 plus 16. Yes, you get 43 when you do this on your calculator. Question 6. If a collision is one in which the two colliding bodies stick together, what is it called? An elastic collision. Okay. There's something I need to talk about also, relative velocity. Let me see this. Basically, we have something called the relative speed of approach and the relative speed of separation. Okay, RSA and RSS. Basically, relative speed of approach basically means u1 minus u2. Yani relative to each other, what's their speed? Relative speed of separation is v1 minus v2. If these two are equal, that means it's inelastic. What does that mean? It's inelastic if the relative speeds are equal. Okay, you need to know this. I'm gonna, let me see, can I find one? Maybe question 5. No, I want one where it gives me speeds. I think there's one here, 7 or 8. Yeah, this one uses, I'll come to it in a second. Okay, I'll repeat this in a sec. Let me just take this up here. Anyways, so here where the relative velocity becomes 0, what does that mean? Yani the relative velocity becomes 0, yani the relative speed of separation and the relative speed of approach are equal. That's what it means. In relative to each other, it's 0. What does that mean? Relative to each other is 0. That means there's no difference between them. Okay, that's what when we say that the relative velocity becomes 0. Question 7. A mass m1 equals 3 kilograms moving. But by the way, into what you need to know, and I'm just saying this in case it's extra. Whoa, what happened? What is this? Whoa. Let me refresh. And I'm just saying this as extra information because sometimes you can get it as multiple choice, and I wouldn't want you getting that wrong. Okay. In elastic, yani relative speed is 0. Okay. Question 7. All you need to know, by the way, is just this one, where they stick together or become embedded. Question 7. A mass m1 3 kilograms moving at 4 meters per second. So m1 u1. Okay, with mass m2 u2, but moving in the opposite direction. So let's take it as -8. Okay, if the collision between the masses is perfectly inelastic, mass m1 will move with the speed of something. Okay, perfectly inelastic, what does that mean? The final velocity v1 is equal to v2. Okay, I'll just write this from now. Okay, so m1 u1, we're going to use the formula m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Right, since it's perfectly inelastic, they're stuck together, so v1 is equal to v2. So we put them, you can just add them together. Okay, type m1 u1, so 3 times 4 plus m2 u2, 2 times -8 is equal to m1 3 v, we're just gonna say v, plus m2, which is 2, and then v. Okay, so you're gonna get so 12 minus negative 4 is equal to 5v. So you're gonna get v is equal to negative 0.8 meters per second, but they said speed, it's 0.8. Question 8. Okay. Two toy carts of masses 200 grams and 400 grams are projected towards each other, each at 4 meters per second. Okay, فهيدي ال M1 هيدي ال M2 وال V. Let's take sorry, U مش V. We're gonna take U to be U1 to be 4 meters per second and U2 to be negative 4 meters per second. Okay, why? Because they're moving towards each other. For one of them has to be positive, one has to be negative. Okay, let's take it like this. Okay, moving هيك moving هيك. Okay, plus 4 meters per second M1 هيدي M2 negative 4 meters per second, taking this to be the positive. طيب, experiment 1. A light spring is tied to the side of one of the carts, making them elastic, and another one where it's perfectly inelastic. Which of the following compares the relative speed of the toy cars in experiment 1 and experiment 2? طيب, in experiment 1, we said it's perfectly elastic. For what does that mean? That means, is there going to be a relative speed? Is it going to be 0? No, it won't be 0. Since it's perfectly elastic, there will be a relative speed. However, when we said it's perfectly elastic, we said that the relative speed is always equal to what? 0. And the relative speed of approach is equal to relative speed of separation, right? So what does that mean? Which one is going to have a higher relative speed, the elastic collision or the inelastic? Obviously elastic. So that's why in experiment 1, the relative speed is greater than experiment 2. Okay, then which of the following correctly compares the speed of the center of masses of toy cars after collision in experiment 1 and experiment 2? This you can take as a rule. Okay, why? The speed of center of mass. The same way we said position of center of mass is M1 x1 plus M2 x2 over M1 plus M2. This is the x of center of mass. The velocity of center of mass is the same thing. Instead of x, what do we use? V. So M1 V1 plus M2 V2 over M1 plus M2. طيب, نحن what do we know about momentum? We know that momentum is conserved. So P initial is equal to P final. طيب, نحن what's this? What's M1 V1 M2 V2? Isn't that momentum? Yes. طيب, okay, we know that in both cases, elastic and inelastic, momentum is unchanged. So that means the velocity of the center of mass of the system, no matter any collision, it's the same for both elastic and inelastic. Okay, you need to know this. Okay, always know V center of mass conserved, provided what? There's no external forces acting on it. Okay, يعني إذا I came and I added an extra push to experiment to the other cart, then أكيد there's gonna be now an external force which is gonna speed it up. So I'm saying, provided no external force acts on it, the velocity of center of mass is conserved. Okay, what's the speed of 200 gram cart after collision experiment 1 and then experiment 2? Let's see. In experiment 1, اتفقنا it's elastic. So let's do it. M1 U1 plus M2. Okay, for this one, you can solve it easily. But the way you can solve it, it's a bit long and you need to use the simultaneous equation. I'm going to go through it now, okay? And then I asked, because I asked ChatGPT, I was asking, is there any other way you can solve it? Apparently there's another way where, basically why I'm telling you it's long, because you need to solve both of these equations together, okay? And you're going to work with square roots and whatever. It's very, 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 very annoying to work with, okay? It's giving me a formula here, actually, which looks nice. Well, I think this is way better to use than solving these two simultaneously. Okay, either way, I'm gonna solve them and show you why I guess the formula ChatGPT gave me is easier. Okay, M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2. Okay, M1 اتفقنا it's 0.2, right? U1 it's 4. M2 is negative 0.4, sorry, is 0.4, but the U is negative 4. Equals M1 V1, so 0.2 V1, plus M2 V2, so 0.4 V2. Type. Let's simplify, you're going to get 0.8 minus 1.6 is equal to 0.2 V1 plus 0.4 V2. This is a bit ugly, it's going to be negative 0.8 equals 0.2 V1 plus 0.4 V2. clean it up a bit. Let's just multiply everything by 10. You're gonna get 8. Negative 8 is equal to 2v1 plus 4v2. I think we can make this a bit nicer, right? We can find an expression for let's say v1. You're gonna get v1 is equal to minus 8 minus 4v2 over 2, which is just minus 4 minus 2v2 as v1. Okay, so you got this now. And then we know that kinetic energies are conserved in elastic collision. So K initial is equal to K final. You're going to do half m1v1 squared plus half m2v2 squared is equal to u not v initially is equal to half m1v1 squared plus half m2v2 squared. This, it's gonna take you too long, okay? Because you're gonna get an equation here and you're gonna substitute this into that. It's a pain. It's a huge pain, okay? I'm gonna continue doing it, and again, you wanna skip, go ahead and skip. Be my guest already. I understand why. So I'm just gonna explain it for the sake of explaining. Okay, so you're gonna get half the mass 0.2 times u1, which is 4 squared, plus half the mass of the other one, 0.4 times u2 squared, which is 16. And you know what, let's just cancel half. We can cancel half everywhere. Okay, you can get this equals m1 v1, so 0.2 v1 squared plus 0.4 v2 squared. So you're gonna get 0.2 times 16. I'm just gonna go through this a bit quickly. 0.2 times 16, you get 3.2. Okay, and then here's 0.4 times 16. You can just multiply it. So you're gonna get 6.4 is equal to 0.2 v1 squared plus 0.4 v2 squared. So you're gonna get 9.6 is equal to 0.2 v1 squared plus 0.4 v2 squared. Let's multiply by 10. You're gonna get 96 is equal to 2 v1 squared plus 4 v2 squared. So you now have two equations, right? And you know this. Let's see if we can find an expression for v1 squared. If you take 4v2 squared to the other side, you're going to get v1 squared and divide by 2. You're going to get v1 squared is equal to 96 minus 4v2 squared over 2, which is just what v1 squared is equal to. 96 divided by 2 is 45 plus 48. And then 4 divided by 2 is 2. So you now get these two. Okay? And you're gonna have to solve these simultaneously. That means plug this in and then solve. Let me continue and see and if I'm going down the right way or not. You're gonna have to now plug in this. Okay. You can square. You have to square this one here to make it look like this square here. So you're gonna get when you do minus 4 minus 2v2 squared, it's the same as doing a plus b squared. You're gonna get, yeah, since they're both negative. Anyways, I'm gonna speed this up a bit. You're gonna get, let's write down the original one. 48 minus 2v2 squared is equal to, let's square this now. You're gonna get a squared 16 minus 2ab, so like it's gonna be wait, since they're both minuses, it doesn't matter. For plus 2 times 4 times 2 v2 plus v2 squared plus this squared, so it's gonna be 4 v2 squared. Type, you're gonna continue a bit. 16 plus 8 times 2, 16 v2 plus 4 v2 squared. Okay, and then we're gonna move everything to one side. I know this is very long, but this is why I'm telling you I want to use the ChatGPT formula. I think it's better. It's way better than this. So 4 plus 2, 6, and then 16. No, 16 stays the same, and then 16 minus 48 over here. You get 4 over 3 and minus 4. Yeah, low key, I'm not solving all that again. I don't know how I got the wrong answer. I'm trying to see. There's nothing I think I did wrong here. I can see maybe in the simplification. Anyways, I installed it again. This is what I'm telling you. Let's take the ChatGPT formula. Okay, so I'm just gonna erase all of this. If you know what I did wrong, please correct me in the comments. But I'm gonna show you the ChatGPT formula. Okay, skip here if you wanted to find it out. Okay, for any elastic collision, if you're not given v2 and v1 and you're only given the first two velocities u1 and u2, you can find v1 by doing m1 minus m2, yeah, m1 minus m2 u1. Okay, plus 2m2 u2 okay, over m1 plus m2. So if you want an easy to memorize this, you can just think of it over m1 plus m2 always. Okay, and let me write this for v2 as well. You get m1 minus m2 u2 plus 2 m1 u1 over m1 plus m2. If you want to just look at it, the easy way to memorize this, you always have this m1 minus m2, you always have this 2 times, okay, and you always have this m1 plus m2. Okay, what's the difference between them is the u1 being here and the u2 being here. Sometimes, depending if you're finding velocity 1, that means you want to find velocity 1. You can remember it like this. Oh, you want to find velocity 1. Yani, the thing that needs to change now is u1. I don't know. These are just things you can think about to help you memorize. But anyway, memorize this formula and you should be okay. Let's see. v1. You get this, by the way, from solving what I did before erasing. But I'm pretty sure I did some miscalculation. Okay, so you can get v1 is equal to m1 minus m2. We took this as m1. We took this as m2. Okay, m1, so 0.2 minus m2, 0.4 times u1. We're going to call it 4 meters per second, right? Remember we said u1 is 4, u2 is negative 4. Type m1 m2 minus m1 m1 minus m2 u1 plus 2 m2 u2, so 2 times 0.4 times negative 4 over m1 plus m2, so 0.6. Let's see, does this work? Over here, 0.2 minus 0.4. Let me put the over here times 4 plus 2 times 0.4 times negative 4 على 0.6. You get minus 6.66667. So over here, which is the correct answer, huh? So you're gonna get minus to one decimal place minus 6.7 meters per second. But they said speed for 6.7 works completely fine. Okay, so we're gonna take 6.7. If it comes in written, this formula should definitely be accepted. Okay, I'm gonna speak to the head of physics in my school and tell him about it. But it should definitely be accepted. There's no reason why it shouldn't be accepted, because it's just the same thing simultaneously solved. Okay, then for the second one here, they're saying in experiment 2. So they don't want v2 for experiment 1. They only wanted v1 for experiment 1. So we're done with this formula. In experiment 2, it's very easy. When it's inelastic, we know how to solve it. We do m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. But since it's inelastic, these two are both counted as v. m1 u1, so 0.2 times 4 plus m2 u2, so 0.4 times negative 4 is equal to m1, which is 0.2 v plus m2, which is 0.4 v. Okay, so you're going to get 0.2 times 4 plus 0.4 times minus 4. You can get this and then divide by 0.6. You're going to get v is equal to negative 1.3 to one decimal place. And they said speed, you take it as positive. Okay. In conclusion, what can we conclude? For elastic and inelastic collisions, okay? In elastic collisions, if they ask you to find the speeds after, but you don't have v1 nor v2, but you only have u1 and u2, use the formula that I wrote. v1 is equal to m1 minus m2 u1 plus 2 m2 u2 over m1 plus m2. And if it was v2, just swap all the speeds with 1 and 2, okay? Not too hard. Remember, if it's an inelastic collision, the relative speed is 0. And if it's elastic, the relative speed actually exists, okay? And remember, speeds of center of mass is always the same no matter what experiment. So this is like a quick summary on conservation of momentum and energy. Okay, this one, question 9, again, collisions عادي. But here you're working with 2D. Okay, now we worked with one dimensional and that's completely normal. And when u1 plus m2 u2 equals m1 v1 plus m2 v2. Completely normal. Hella with a two-dimensional collision, it's the same exact thing, except you split up your velocity into a vector I and a vector j. Okay? This is the way I solve. Some other teachers solve differently. That's completely fine. I find this the easiest way. Okay? Basically, when you have angles, and this one is fine, it's 90 degrees. You know, this is completely easy. But later on, question maybe 13, I think I saw it. You need to use angles, you need to use vectors, okay? طيب, a ball of mass 2m moving at 10 meters per second collides with a heavier ball of mass 6m, okay, stationary. Okay, so we're going to call this m1, and we're going to call this u1, we're going to call this m2, and we're going to call u2 0. The lighter ball bounces off at 90 degrees with its original direction at 1 meter per second. Okay, at 1 meter per second. For v1 is equal to, let's call this, let's just call it v1. I'll elaborate in a bit. Okay, and that's, I don't know, 90 degrees. Okay, so this is before the collision comes, it hits it, and then I see after the collision bounces back up at 90 degrees. The second you see two-dimensional, or any degree, every velocity, I need you to express it as a vector. Okay, so let's take a look. At the start, it's moving horizontally to the right. So as velocity, how do you express this as a vector? 10I plus 0j. Okay, please, this is how you should do it. Okay, if it's a two-dimensional problem or any angle. So we're going to call this u1, we know it's 10I plus 0j. Okay, although they gave you just 10 meters per second, you need to write it like this because you're going to have vectors. This question doesn't really require, but half-half, okay? You can solve it with both. But I don't want you to be lazy and solve it the easy way, because if you solve it the easy way, you won't learn it for question 13. طيب. The second ball, we know it's 0, that's fine. The lighter ball now bounces off at 90 degrees with its original direction at 1 meters per second. So now it bounces off at 90 degrees. So isn't it vertical? So what's the velocity now? It's 0I plus 1j. Right? Because it's going vertically up now. Okay? Since it's 90 degrees. If they told you 50 degrees, you have to calculate it. Okay? Anyways, it's V1. We need to find what is V2. Okay? Same formula. But except now, the velocity is just expressed as a vector. That's completely fine. You know, I should be completely fine. M1 is 2m. U1 is 10I. Plus M2, which is 6m. U2 is 0, so let's just cancel this. Okay, is equal to M1 V1, so 2m times V1 times V1. اتفقنا what's V1? 1j. Okay, plus M2 V2, mass 2 is 6m. V2, we don't know it. طيب, let's do it. You're gonna get, let's cancel m everywhere, okay, to make our lives way easier. You're gonna get 20i is equal to 2j plus 6 v2. Can I find v2? Of course I can. So you're gonna get v2 is equal to 20i minus 2j divided by 6. صح? I just move everything to the left. So what's this? What's 20 divided by 6? It's 10 over 3i minus 1 over 3j. Okay, so this is v2. You see how if you solve it normally, you won't get the same answer. Trust me, you won't get the same answer. So anytime you see any angle, you need to use vectors. Very, very easy to use vectors, really. It's not that hard. Okay, and you get it like this. Someone's going to tell you, طب وليد, instead 3.3, how do you get this? Exactly. طب now we got it as a vector. How do we take the how do we find it? You take the magnitude of it, right? So 10 over 3 square plus minus 1 over 3 squared. 3.3. Sometimes, okay, you get 3.3. Sometimes they ask you at what angle. How do you find the angle if you have a vector? Tan inverse, right? So if you were to do it here, you do tan inverse minus 1 over 3. So you remember, j over I, over 10 over 3. And since, yeah, and you get on degree, what? 10, what's this? Why am I getting 5 degrees? Yeah, anyway, yeah, so that would be the correct. Negative 5.7 degrees. That would be the direction. Okay, so sometimes they ask for it. Okay, moving on. By the way, it makes sense for the angle to be negative because you're going down. And also it makes sense for your I to, for your j to be negative because again you're going down now, based off of this diagram given. Okay, let's continue. I don't want to take too long. Question 10. Consider a 0.5 kilogram toy car that is equipped with an automatic rubber bullet rifle. The car, initially at rest, starts moving when the rifle fires a 0.05 kilogram bullet with a speed of 20 meters in the positive direction, neglecting friction. The velocity of the car after the bullet launches is something. Type. You have a bullet. I think you can kind of think of this as the propeller to the car. Okay, the car is like this, and it has like a bullet launcher. Okay, and it launches bullets. Okay, you guys know. I don't know if you've tried doing something like this. If you want, how can I like? Yeah. مثلا, I'm trying to think of an example. I'm sure some of you have played games before where you hold your fire extinguisher, okay? And when you shoot the fire extinguisher, basically, it kind of propels you, if you get what I mean. Okay, over here, fire extinguisher. This is you, okay? And you have your fire extinguisher, and basically, you shoot it, and I'm kick. Okay, and you shoot the fire extinguisher and it throws smoke out, right? And when you shoot the fire extinguisher, doesn't it push you backwards, right? Because it's like you're pushing all this air out. Exactly, it does. Okay, so this is what this example here is. The reason to this is actually because of the conservation of momentum. For until you push to the left, create a momentum of I don't know, let's say 5 kilogram meter per second. Then to the right, it will also be matched with 5 kilogram meter per second. These are actually very interesting videos you can look up online. A video example, a real life example of conservation of momentum, and they're very nice examples actually. So basically, our gun here is going to shoot bullets, and this will cause some momentum that will push this to the left. Okay, let's see how will it work. We're going to do this M1, U1. Wait. Yeah, we're doing, since it's not really a collision, but you can use this for it applies for all of them. M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2. Okay, we're gonna call this 0. Why? Because the car was at rest. Okay, M2 U2, we're saying they gave us it in the positive direction. When they give you the directions, you have to follow what they give you. Okay, you're not allowed to do otherwise. Type. So obviously M2 U2 is also 0 because it still didn't start firing. So you're left with M1 V1 plus M2 V2 is equal to 0. Okay, so let's take a look here. M1, we're calling the car M1 0.5. V1, we're trying to figure it out. Plus M2 V2. M2 is 0.05. It's the bullet. Okay, V2 is what? 20 in the positive direction is equal to 0. So you're gonna get هيدي بتكون 0.5 times 2. You're gonna get, I think, 1 over 2. Yeah, 1 over 2 plus 0.5 V1 is equal to 0. So you're gonna get, is it 1 over 2? Let me see. It's 0.05 times 20. It's not 1 over 2, I think. It's 1, yeah. It's 1 here. Plus 0.05 times 20. Let me replace it with 1. Okay, so you're gonna get V1 is equal to negative 1 over 0.5, which is negative 2 meters per second. The negative counts because they said velocity, not speed, huh? طيب. Question 11. I'll not waste too much time on these easy questions. A sphere A of mass 3 kg lies dressed on a smooth horizontal table. I can't speak English anymore now. M1, we're going to call it 3, and U1 is 0. A second sphere of mass 1 kilogram, so M2 is 1 kilogram, moving with a speed of 2 meters per second, so U2 is 2 meters per second. The two spheres combine after impact. What does this mean? Inelastic, right? What's the speed of spheres A and B? Yalla, M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2. Don't forget to take a positive direction. Take the right as positive direction. Okay? So that means M1 3, this is 0. Why? Because it's at rest. M2 is 2, so it's 1 kilogram, times the U2, which is negative 2. Why is it negative 2? Because we're taking the right to be the positive direction, okay? Is equal to M1 V1. Since it's an inelastic collision, they move with the same speed, V1 and V2 can just be rewritten as V, okay? M1, to find that's 3 times V, right? Plus M2, which is 1 times V as well. So you're going to get 4V is equal to minus 2. You're going to get V is equal to minus half, which is minus 0.5 meters per second, which they took as the speed, so they took the positive answer. Question 12. A ball P moving at 6 meters per second hits an identical ball Q moving at 4 meters per second in the same direction as P. After impact, both balls move in the same direction along a straight line. After impact, the speed of Q, VQ, is triple that of P, VP. طيب يعني VQ is 3 times VP. Okay. What are the speeds VQ and VP after collision? Type, what do we know? We're going to do, it's a collision. I didn't say anything about them being stuck together or whatever. They just said they move in the same direction. That doesn't tell me that it's inelastic. So we're going to continue using M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2. They didn't really change direction, but so if you take the positive as the right, nothing really is going to change since you're always moving in the right direction here. M1 U1. Ball P. We're going to call it mass of P. U1 is 6 plus mass 2, which we don't know. I think we just count mass of Q, times U2, which is 4, is equal to mass of P times V1, which we're just going to call VQ. Sorry, what? We're taking P as, VP, plus mass 2, which is mass of Q times VQ. Okay, what do we do here? Because I have two unknowns. Guys, I might be stupid. They said identical ball, so you can cancel out the masses everywhere. Because it's the same balls, so they have the same mass. Okay, so you're gonna get 6 plus 4 is equal to VP plus VQ. This is very, very easy. So 10 is equal to VP plus VQ. We know VQ is just 3VP, so you can substitute this, right? So you're gonna get 4VP is equal to 10. So you're gonna get VP is equal to 10 over 4, which is 2.5 meter per second. واتفقنا انه VQ is 3VP, فit's 3 times 2.5, which is 7.5 meters per second. Okay, very easy, very nice. Question 13, this is the one with angles, I think. Yes, okay. A toy car of mass 2.6 kilos moves from rest down a smooth, long plane inclined at an angle of 24 degrees with the horizontal. It collides with another mass over here, نحط الcar here. Okay, it collides with another mass 1.9 kilograms after 3 seconds. The second car was already moving down the inclined plane at half the speed of the first car at the moment of impact. Given that the two cars combine after the collision and continue moving down the plane, their common velocity after 1.4 seconds of the impact is what? This is a very, very, very يعني بدها شوية like solving. Okay, I'm gonna take a longer incline plane because مبين إنه they stuck together for a bit. Okay, let's call this M1. Okay, it's moving from rest, for U1 is 0. Okay, long plane inclined at an angle of 24 degrees over here. Okay, we're gonna say 24 degrees. And then it has another mass over here. Okay, over here. We're gonna call this M2. And it collides after 3 seconds. Okay, the second car was already moving down the inclined plane at half the speed of the first car at the moment of impact. So we can say that at the moment of impact, V2 is equal to half V1. Okay, given that the two cars combine, we're gonna call this U. Okay, U. Okay, we're gonna ignore this here. Okay, we're gonna call these U. At the moment of impact, let's just say U1 is equal to the second car, U2 is equal to half U1, right? Second car is equal to half the first one. So we're just writing down the given for now. Okay, and since it's inelastic, they combine, yani V1 is equal to V2. Type. Let's solve. Okay, so this took me a few steps, but I got it in the end. It took me a good 3 minutes to solve. Anyway, collisions, don't waste your time. Write down what do you know. Okay, let's say you're stuck. Write down what do you know. M1 U1 plus M2 U2 is equal to M1 V plus M2 V, right? Because we can write V1 V2, but we know they collide and stick together if they have the same velocity. Type. Let's plug it in. 2.6 times U1 plus 1.9 times U2 is equal to 2.6 V plus 1.9 V. Let's just simplify this a bit. Okay, you're gonna get this. Type. What were you missing here? We need U1 and U2. So here's a small problem, right? How can I find U1, U2? I don't have anything given. But what do I have given? I have that it starts at rest. Okay, so it starts initially at rest. When it collides with it collides after 3 seconds. Okay, type. نحنا, we have 3 seconds. Do we have any acceleration? Do we know any velocity? What do we know? We know that it's a cart. It's FBD. I'm going to draw the FBD just so you can understand. It has its weight going down like this, right? Type. I'm moving horizontally, right? I have WX. This is 24 degrees, of course. WX and WY. Is there any force that can give me acceleration? Always take this as a rule for you. What causes you to start accelerating down a plane? Your weight. Okay, but which component of the weight is going to be the full weight, mg? No, obviously not, right? My x component of the weight. Fine, let me redraw it for you. Okay, if my weight looks like this, the x component of the weight is what's going to bring me down and accelerate, right? Type. So we know sigma fx is equal to ma. So if you see this question in your exam, inclined plane, whatever, immediately do wx is equal to ma, provided there's no external force. Okay, if there's no external force, you do this straight away, because the weight is what causes you to accelerate. Take it as a rule. What's wx? It's mg sine 24. Why sine? Because they gave me the angle of the inclined plane, which is with the vertical, is equal to ma. You can cancel m with m. You're gonna get a is equal to g sine 24. So 9.8 times sine 24. Type. Perfect. Can I find the velocity now, knowing that my acceleration is 3.986 and I used it for 3 seconds? Can I find velocity? Of course I can. V is equal to at plus u, right? But u is 0 because we started from rest. Okay, so we're gonna get v is equal to acceleration times time. So 3.986 times 3. You get 11.96. So what does that mean? That means u1 is 11.96. So over here I can substitute 11.96. Perfect. How about u2? What do we know about u2? They told me u2 is half of u1. They said that it's half the speed of the first car. If I divide this by 2, a debit lalak 5.98. Okay, is equal to 4.5 v. Now can I solve? Of course I can. Okay, so you're gonna get 2.6 times 11.96 plus 1.9 times 5.98, and then you're gonna divide this by 4.5. Okay, we got 9.435. Someone's gonna come tell me, Walid, it's 15 meters per second. Keep shipped to the cake. After 1.4 seconds, for same thing, they collide. Okay, but you're still on the inclined plane, so you're gonna still continue to accelerate. For after 1.4 seconds, your velocity should be higher than the moment of impact. This is at the moment of impact. They said after 1.4 seconds. So we're going to follow the same rule. V is equal to AT plus U and find the velocity after 1.4 seconds. Do you need to find the acceleration? Yes and no. We already found it. We already found that the acceleration is 3.986. Someone's going to come tell me, Tab Walid, isn't it like a different weight now? Why is the acceleration the same? Take it as a rule, okay? You're always going to get Wx is equal to ma, right? Type Wx is equal to ma, so mg sine 24 is equal to ma. No matter what you do, these masses will cancel, okay? So you're always going to end up with the same acceleration, which is g sine 24, which is 3.986, okay? It doesn't mean the exam put 3.986, but they might change the angle in the exam. فانت you know a is equal to 3.986 from here. You can refine it and resolve it using the same method I used here. عادي, but that's your choice. I'm going to continue using it immediately because I know خلاص acceleration is the same. Since we're on the same inclined plane, we didn't add any force. There's no reason for the acceleration to change. Okay, 3.986 times the time, 1.4, plus how much were we moving at initially at the instant of collision? 9.435. Okay, plus 3.986 times 1.4 to the nearest integer is how much? 15 meter per second. So to recap, you need to find the velocity. You need to find u1 and u2. Since they gave me the time and they gave me the gravitational acceleration, I can easily find the velocity. Since if I can find acceleration times time, I can find the velocity. Okay, so if you see a question like this where you can't find the velocity but you have the time, just use acceleration times time to find the velocity. To find acceleration, use what I did here. Okay, a particle of mass 2.5 kilograms has linear momentum of 4, and we don't know the velocity. Okay, what is the kinetic energy of the particle? Half. Okay, kinetic energy is equal to half mv squared, but we need the velocity type. Okay, v we know p is equal to mv, right? So that means v is equal to p over m. So 4 divided by 2.5, which is, I have no idea, صراحة. Loot in the calculator. 1.6. Okay, so v is equal to 1.6. So what does that mean? Kinetic energy half times the mass 2.5 times 1.6 squared times 0.5 times 2.5. It's 3.2 newtons. The newtons should be joules. The unit is wrong, huh? Question 15. Two identical pucks of mass A and B are moving along the same straight line on a hockey table. Puck A moving with speed 2.1 strikes puck B moving with an initial speed of 1.5. U1 هيدي و U2. After the collision, both pucks move in the same direction, but the speed of B is 0.6 meters per second greater than the speed of A. This should be very easy. The speed of puck B after the collision, and then, okay, type. M1, it's elastic, obviously, because it didn't stick together. We want to find the velocity, so M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2. Are the masses identical? Yes. Bam, 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 bam. U1 at day 2.1, with the other one was 1.5. It's in the same direction, equals V1. We don't know, we're just going to call it VA and VB. We know VB is 0.6 plus A. Okay, so VB is equal to 0.6 plus VA. طيب, we know this is equal to V1 plus V2. Okay, let's just call them A and B. What do we know VB is? 0.6 plus VA. So 2.1 plus 1.5 is equal to 2VB plus 0.6. If you substitute VB as 0.6 plus VA, you're going to get 2VA plus 0.6 VA. Let me erase that. Okay, 2VA plus 0.6. Hella, okay, you're going to get 2.1 plus 1.5 minus 0.6 divided by 2. You're going to get 1.5 as VA. Okay, and they're asking for speed of B, which we said is 0.6 plus A. So VB is 0.6 plus 1.5 equals 2.1 meters per second. Okay, very easy. Due to the collision, puck A loses something in momentum. So basically, look at puck A, look at its initial momentum and its final momentum. Initially, for A, how much was the momentum? mv. So the mass of A, let's just call it m. They said call it m. right? Times the velocity of A initially was 2.1. And then finally, for A again, it's equal to the mass of A, which again is m, and the velocity of A is what? After collision, it's 1.5. So initially the momentum was 2.1 m, after it was 1.5 m. So how much did it lose? It lost 0.6 m. The loss of kinetic energy due to the collision. Is it an inelastic collision? Is it inelastic? شايفين شيء inelastic? Did they stick together? Did they embed? No. So that means kinetic energy is conserved, so there should be zero loss. Okay. However, should you check it? Why not? You know what will you lose if you check it? Okay. Initially, K1, it's equal to half m. Since it's the same mass, you can just factor out half m and do v1 squared plus v2 squared. You know, I'm not gonna do this. This might confuse some people. So half m va squared, which is just 2.1 squared, plus half m 1.5 squared. K2 finally is half m. For A, it's now 1.5 squared. No, well, 1.5 squared plus half m 2.1 squared for B. Aren't these just the same thing? Yes. Without calculating it, you can get, it's obviously the same thing. Okay, so there is zero loss. Type. Question 16. Yeah, 2 more questions. Inshallah, they're easy. A small sphere of mass 5 lies lies at rest on a horizontal table. A second small smooth sphere B of mass 2 kilograms moves with 4 meters per second, collides directly with A. They combine after impact, right? So it's inelastic. Type. What is their common speed after impact? Yalla. m1u1 plus m2u2 is equal to m1v1. No, we're just going to say m1v plus m2v. Why? لأنه it's inelastic, فthey're combined, they have the same velocities. Let's call A. Let's call this m1 and u1. u1 is equal to 0, for m1 u1 is 0, right? Because it's at rest. Type. m2 u2 at day 2 times 4 is equal to m1v, فيعني 5v plus m2v at day 2v. For 7v equals 8. For v is equal to 8 over 7, which is 1.14. What is the loss of kinetic energy? طيب, since it's obviously inelastic, معناتها obviously there's going to be loss of kinetic energy. So you need to find it. K1 is equal to Ka plus Kb. I'm going to quickly say Ka is 0 because it's at rest. Okay? I'm not going to waste my time. Half times the mass of B, which is at day 2 times 4 squared. So which is 16 joules. K2 is equal to Ka plus Kb. Let's say Ka prime and Kb prime. So Ka prime, which is half times the mass of it, which is 5 times the new velocity. They're both 1.14 squared, right? Since they're both combined together, they both have the same velocity, which is 1.14, right? So that times 2 times 1.14 squared. Let's do this on our calculator. 0.5 times 5 times 1.14 square plus 0.5 and 2 cancel, half and 2 cancel, 1.14 squared. You get this, and then 16 minus whatever this is. You should get 11.45, which is just 11.5. Question 17. A 50-gram bullet that is traveling at 450 meters per second collides with a 4 kilogram wooden block and becomes embedded in it. What does this mean? Inelastic collision. طيب, would you consider it? Part A. Obviously inelastic, yes, because it's embedded. طيب, the velocity of the bullet block system immediately after collision is how much? m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. A wooden block at rest, so we're going to take this as m2, and we're going to say v2 is equal to 0. Okay, so that's why we cancel this as 0. We're going to take this as m1 and u1. Type m1 0.05, because it's in grams, times u1, which is 450, is equal to, since they collide in the same velocity, m1 is 0.05. We can say v, not v1. v1 is equal to v2, since it's embedded in elastic collision, same velocity, they're stuck together, right? Plus m2 v2, say 4 v2. حلا, you're gonna get 0.05 times 450, and then divided by whatever that is. You get 5.2, the nearest decimal place is 5.6 meters per second. Easy. The percentage of kinetic energy dissipated as heat. Okay, so basically we want to see how much kinetic energy did we lose. To do that, we need to first compare kinetic energy. K1 is equal to Ka plus Kb, which is the block is 0. Let's see how much. Why is it at 0? Because it's at rest. How much is the bullet? It's half times the mass of the bullet, 0.05, times the velocity of it squared. Let's do it. 0.5 times 0.05 times 450 square. 5062.5 joules. Type K2, at day K2, it's half the mass of the bullet, which is 0.05, times its velocity now is 5.6, we're going to say squared, plus half times the mass of the block 4 times its velocity squared, which is 5.6 squared. Okay, this should be way smaller, صراحة. 0.05 times half, which is 0.5. Whatever, you guys know how to put it into a calculator. Plus 0.5 times 4 times 5.6 squared, you get 63.504. طيب, you need to find the percentage change. They're not asking how much did it change by, the percentage change. To find the percentage change, here's what you do. Okay, to find any percentage change, it's delta of let's say you're comparing kinetic energy. To find the percentage change in kinetic energy, it's delta K over K1. To find the percentage change in anything, it's always the change over the initial amount you're comparing it with. Okay, so 5062.5 minus 63.504. You can do this minus this the other way around, but you're going to get a negative percentage. That doesn't matter. Over the initial one, which is 5062.5. يلا بالكالك. 5062.5 minus 63.504 over 5062.5, obviously times 100. You get 98. This should be 99%. Yeah, 99%. We're done. Thank you so much for watching and good luck in your exam.